So hi guys, today we are going to work on the multiple linear regression. We have this tiny data set which is CGPA, IQ and the placement. We will have these two columns and then we need to predict what will be the placement of a particular student, right? So we will start. Let's suppose this is like you can imagine that y1 equals to 8, y2 equals to 7 and then y3 equals to 5, right? We don't have y1 hat, we need to find it. We need to find y2 hat, which is a kind of predicted value, right? We have these actual values, we need to find these predicted values, right? If you remember the single linear regression which was equals to y equals to mx plus b, right? So this is a kind of a multiple linear regression. So y1 hat will be can we will call it as beta of 0, then we will call it then beta of 1 x 1 1, which is this value, right? And then we will call it beta of 2, since this is the multiple linear regression depends upon more than one column, so import in simple words. And then we will call it 1 2. In the same way, if we calculate y2 hat, then it will be beta of 0 plus beta of 1, then it will be 2 1 plus it will be beta of 2x 2 2, right? And in the same way, if I calculate the y3 hat, then it will be beta of 0 plus beta of 1 x 3 1 and then x beta of 2 x 3 2, right? So if you consider this thing, can I write this thing like y capital? This is like this is the lowercase y and this is the capital Y. Can I write this thing y capital hat equals to, and inside it I can pass, there will be for this equation will be valid for uh, m number of columns, right? For m number of columns. So y1 hat, y2 hat and up to so on y m hat, right? So if you consider it, what will be what is its order? Its order is m, like how many rows it has? It has n number of rows multiplied by one column, right? In the same way, if you consider these beta values as well, for m number of columns if we have, then can I write like this thing? Uh, if how we can get this kind of result? Let's suppose I write this thing, which is uh, here I will write y1 hat, y2 hat, and then up to so on ym hat, right? And if I multiply this thing with my beta, which is a kind of beta of 0, then will be beta of 1, up to so on it will be beta of m as well, right? So what is this y1 and y2 and y3? These are nothing but they are equals to the these equation, like 1, you can imagine, up to go to 0. This is nothing, this column is nothing but the intercept, right? The extra one, intercept. So and then we have x1 1, then we have x1 2 and up to so on we have x up to n 1 m as well, right? In the same way we have x 2 1, x 2 2, and then we have x 2 of m. In the same way we have x n of 1, we have x n of 2 up to x n of m. If we multiply these values with these beta kind of values, then first of all let's write their order as well. What is its order? Its order is uh, like m, like there are n number of rows, multiply there are m plus 1 column. Why m plus 1? Because of this extra intercept, right? In the same way, what is its order? Its order is nothing but m plus 1, because of intercept multiplied by 1 means only one column, right? So if we multiply this thing with this thing, we get something like n multiplied by 1, which is the same thing which is which is the dimension of a y hat as well, right? So we can replace this thing with capital X, and we can replace this thing as beta. So the final equation will be y equals to x of b, right? Y hat. So now let's prove it, and let's find some kind of conclusions accordingly. So let me remove it. So if x y equals to, which is the actual values y1 up to so on, and they goes up to like y of m, and then we have y hat equals to y1 hat, y2 hat, and then they go up to y m of hat, right? And let's suppose this is nothing but the dimension is like n multiplied by 1, this is also n multiplied by 1, right? How we can calculate the error? We subtract the actual value from predicted value. This is my predicted and this is my actual, so I will write here e equals to y minus y hat, right? So I will write here y1 minus y1 hat, y2 minus y2 hat, up to so on, it will go up to in minus yn of hat, right? So if I transpose it, means if I write this thing like E transpose of E, and the transpose of its transpose, it will be converted to rho, so it will be like y1 minus y1 hat, then y2 minus y2 hat, up to so on, and we multiply it with the real without having the transpose, y2 minus y2 transpose, sorry, hat, and then we have y n up to yn of hat. And if we multiply this thing, we will get something like y1 minus y1 hat square, right? And then we plus y2 minus y2 hat square, and it will go to the yn minus yn hat square, okay, right? And if you consider it, can I write something like sigma of n I equals to 1, and inside it y of I, which is my actual value, and then we have y I of hat, which is my kind of predicted value. So if you remember, this thing is the kind of loss function we calculated for a single linear regression, which is equals to E, or we can call it anyone. So can I write this thing like E equals to E t of E, as this thing becomes equal to E, and we have E t here, so we can draw this thing, this equation, right? Okay. Now we'll work on this equation. We have right now E t E equals to E, and E equals to, since E is equals to nothing but y minus y, right? So if I put this value into this equation, what will happen? It will be like y minus y hat transpose into y minus y hat, right? So let's multiply it, y into, it will become y transpose y minus, it will be y hat, it will multiply like this thing, and then we have y hat of we transpose here, and then we y hat, and then we have y hat of transpose y plus y hat of t, and then we have y transpose, right? So first of all, I want to prove here this thing. These are these two things are same. If we prove these two things are same, so we can write something like if this is 1 and this is 1, means these are same, we can write 2 here, right? Means we will add that if we prove that this thing, this value is equals to this one. So in order to prove this thing, what we need to do, so let me write it here. y transpose y hat equals to y hat transpose of y. We need to prove this. So let the y equals to a and y hat equals to b. Then the equation will be like a transpose of b equals to b transpose of a. Our goal is to prove this equation. So if I write this thing like a transpose of b whole transpose, then it is equals to b transpose of a. We need to find this kind of relationship, right? So this thing is only true if the A transpose B is symmetric. As you know, the symmetric the transpose of symmetric matrix is the same of the equal to the original matrix, right? So here what I will do, I will write here since you know that y equals to y hat equals to x of b, the equation we draw earlier. So can I replace this value like in the equation y xb? If then the equation will become x transpose of y hat, or equals to, it will be y transpose and y, and then we have x of beta, right? So we have y transpose, and then it is the equation becomes like this thing, right? And then what we need to do, we will like we'll first of all multiply x with b, right? And if you remember the dimensions of x, it was like the beta dimension was like n plus 1 multiplied by 1, and x dimension was n multiplied by n plus 1, right? So these two become same, so our result will be equals to n multiplied by 1, right? If you remember that y hat dimension were also n multiplied by 1, and if I multiply this thing with the if my question is, if the dimension of y hat equals to n multiplied by 1, then y hat transpose will be 1 multiplied by n, right? So 1 multiplied by n, here n multiplied by n, and there goes the, so these two values become same, so y result will be 1 multiplied by 1, which is nothing but n, what is what? 1 multiplied by 1 is nothing but a scalar matrix. And scalar matrix has the, so if we transpose it, then the original it equals to the original matrix, right? So we prove that. So here goes the 1 multiplied by 1, and if you consider this thing as well, this is the same thing, like n multiplied by 1 multiplied by 1 multiplied by 1. So this is the dot product, so we will get something like this is y transpose, so it will be 1 multiplied by n, and this is my original y, so it is n multiplied by 1. So we'll get something 1 multiplied by 1 here and 1 multiplied by here as well. So left hand side becomes equals to right hand side. So we can conclude that these values are equal. So we will replace this equation, y transpose of y minus 2 y of transpose y of hat plus y hat of transpose, and then we have y hat, right? And now we will start from here again. So we have this equation, right? We have equation like E equals to y transpose of y minus 2y transpose, then we have y hat plus y hat transpose, and then we have y hat, right? If you remember, y hat equals to x of beta. So we will replace this thing like y transpose y minus 2y transpose x of beta plus x beta into y x beta of transpose y hat, am I doing a mistake here? Y hat equals to x of beta here, and it will be like x of beta, its transpose, and this is also y hat, so it will be also like x of beta. So let's solve this equation again. So it will be transpose of y minus 2 y transpose of x of beta plus this equation x of beta of transpose will become like beta of transpose, x of transpose, and then we have x of beta. Am I right? So we have this kind of equation we find. So from this equation we can draw the conclusion that E is dependent on which thing is dependent on beta. So we need to find an equation for which the value of for particular value of beta, the value of E become smaller, right? The value of E we need to make it small. So loss function is nothing but a kind of like this thing relationship between E and beta. So it will be like in this way. So we need to find this kind of minima, which is uh, at which the slope become equals to 0, right? So we will make the slope, which is this slope, equals to 0 in order to find that kind of minimum value, right? So we will write something like d of E over d of beta into, and our value y transpose of y minus, then we have 2 y of transpose, and y of beta, y of x of beta, and then we have beta of transpose, x of transpose, then we have x and b as well, and this one. So if we derivative if we took a derivative based upon like b, then this thing will become 0, this thing will become 2 y of transpose of and this will become x, and this thing will become 2 beta of transpose x of t, right? So and it's like a kind of equation which you will study here, like if the alpha is equals to x of transpose and then a of x we have, then the answer should be x of t and a, where a should be according to the it should be like symmetric accordingly. Okay. So here we made this equation, and from this equation we can simply conclude like this thing: beta 2 beta of t x of t equals to 2 y of t x. This will be cancelled. So beta of t x of t, and here there were like and there will be the x as well, 2 beta of t x of t, and here goes should be x as well, so it will be x equals to y of t of x, right? So now what we will do, we will multiply both sides with the x inverse. So we will multiply x inverse, right? So on both sides we are going to multiply by x transpose of x and their inverse as well. So we will beta transpose x of transpose of x will be multiplied with x transpose x of minus 1, and then we have y transpose, and then we have x, and then we have x transpose x, and then minus 1. So if I multiply this thing, I'll get like, if you remember, a inverse equals to a, so this thing will become what? Beta of transpose, it will become like a kind of identity matrix. We will remove it, this is identity matrix here, a inverse and then here goes the y of transpose x into this thing, x transpose x of minus 1, and then If you multiply beta like identity matrix with the some matrix, then that some matrix will be returned. So beta transpose equals to y transpose of x into x transpose of here goes I think x, yeah, minus 1. And then we will, what we will do, we will take a whole kind of transpose, y transpose multiplied by x transpose of x of minus 1, then whole transpose. It will be beta, beta equals to, beta will be equals to we will call it x transpose x minus 1, and it's a kind of whole transpose with y with x transpose of y. And this thing, there is a kind of a complete proof of it, how this value is equals to how x minus 1 transpose equals to x transpose of x inverse, which we will be covering in some other video, because this video has gone long very much. So we will replace this thing by, so our final value will be like x transpose of x, and then we have minus 1, and then we have x of transpose, and we have y as well, x as well accordingly. This value was y transpose, and then we have y. So our final value from this complete kind of equation was beta equals to x transpose x of inverse, and then we have x transpose of y. That's all for our today's session.